Tododikar sir, you can start now. Hello, Tododikar sir.
Yeah, sir. Good afternoon, everyone. Welcome, Dr. Vijay Athawale, sir. Good afternoon, sir. Am I audible clearly, sir?
Yes, yes, yes.
Hi. Yes. Welcome, Dr. Vijay Athawale, sir.
Thank you, sir.
Okay. Good afternoon, sir. The sir is an associate
Good afternoon.
professor in the Government College of Engineering, New Khapri, Nagpur. The sir is brought and born from the Amravati. Sir has done his SSC and SCC from the Amravati University. Sir has done the graduation from Amravati University. Meanwhile, sir has done the master degree from the VNIT Nagpur, and sir has completed his PhD degree from the Jadavpur University, West Bengal. Sir is an expert in almost all the subjects in the mechanical engineering. Sir expertise in the operation research international LSE committee in the Nagpur University. Sir is a reviewer in the International Journal in the Manufacturing. So I welcome Dr. Vijay Athawale for today's session. Sir, good afternoon. You can proceed, sir.
Okay, sir. Thank you, sir. Thank you, Talodikar sir and Ambade sir, for my introduction. Let me share my screen. Okay, good afternoon, dear students. So my screen is visible to you? Is it visible, sir? Hello?
Yes,
Yes
sir.
sir, yes sir.
Okay,
Yes, sir.
okay,
Screen is visible, sir.
okay. Thank you, sir. Now, dear students, in today's 1 hour lecture, as the job given by Ambade sir and Talodikar sir, that I have to complete the overview of power transmission. So, you know that this is the most important topic in the mechanical engineer. So, this power transmission include the power transmission by, say, either belt drive, chain drive, then gears, and then clutches. So again, it is not possible to cover everything within this short span of 1 hour. So I am trying to give some, or I am trying to brush up the details regarding the gears, the gear trains, what are the terminology involved. Then we are mainly concentrating on the belt drives because, sir,
Screen,
hello,
please.
hello, sir, hello,
Sir,
sir. I
screen
have
में
not
नहीं
changed,
दिख
Full.
sir. I have not changed the screen, sir. Yet,
No, screen is visible sir.
hello. Okay. Okay, sir. Thank you. So our main intention is to go into details regarding the drive, that is belt drive. And if time permit, then we will solve some problems, or we will discuss the what are the formulas, how to solve the problems related with the belt drive. Then again, we are going into just overview of gear trains. Then what are the advantages, what are the terminology related with the gears. So these are my, you can say, details regarding this lecture. So we know that power is transmitted by either belt or rope. then chain drive, gears and clutches. Now, from a gate point of view, you may expect the questions on belt drive, then gears also, because there are some terminologies, and that terminology is directly used in design of the gears. So you may expect some of the short problem or MCQ problems based on the gears, at the same time belts, and then clutches also. But as I already told you that I am mainly deals today in today's lecture, I am mainly deals with the belt, then gears. Okay. So belt and ropes are used when the distance between the axis of the two shafts is to be connected is considerable. So when there is a you can say considerable distance between the two you can say shafts and pulleys. So in that case we can go for this belt and this rope drive. But it has some disadvantages. Now disadvantage means what? It is not a rigid joint, because we have to join the two ends of the belt with the help of some clips. So because of that, it may create some noise during its operation. At the same time, there are possibility of slip during the operation. So to avoid that, we are going for the next drive, that is a chain drive. So this drive is again used when the distance between the shaft center is short and no slip is required. So whenever it is expected that there should not be sleep, or sleep should be zero. So in that case, we have to prefer this drive, that is the chain drive. So these connectors are referred as a positive and non-sleep drive. Why positive drive it is called? Because it doesn't sleep during the operation. Whenever there is a slipping of you can say belt over the you can say pulley. So in that case, we can say it is a non-positive drive or negative drive in short. Okay. Then another drive is the gears. So gears are used for transmitting motion and power when the distance between the driving and driven, you can say shaft is relatively small, and when the constant velocity ratio is desired. So this velocity ratio is most important in the design of either gears or belt, the chain drive, and also in clutches. So you may expect some question on velocity ratio also. So there are different types of gear, then there are different types of belt, different types of chain. So you may expect MCQ on this velocity ratio also in the gate examination. So this is the simple arrangement of a you can say belt and rope drives. The transmission of power is factories from one rotating shaft to another that lies at the considerable distance is achieved through belt and ropes. So this is a simple arrangement, and most of the companies they are preferring such type of drives for transmission of power from one place to another, or from one rotating shaft to the another rotating shaft. The shafts are fitted with pulley. The belt is wrapped around the pulley and its end are connected to form a endless connector. Now this endless connector means what? We are specially talking about the V belt drive, because there is no connector in between the just like a belt drive, that is flat belt. In flat belt, we have to connect the ends of the flat belt with some clips, or also called as a connector. But in case of a V belt, this type of connector is not used. So we can say it is an endless connector or endless drive. The belt and the pulley remains in contact by a frictional grip. So this is the most important, you can say, element or concept in the transmission of power. When there is a friction between the two contact surface, only then it is possible to transfer the motion or transfer the, you can say, power from one place to another. So there should be a frictional grip between the pulley and the belt, or pulley and the chain, or sprocket and the chain at the same time in the gears. To explain this concept, let the pulley A, which is connected to rotating shaft, is called as driver, and the pulley B is called as a follower. When the driver rotates, it carries a belt because of friction that exists between the pulley and the belt. So because of the friction between the two contact surfaces, there is a you can say both the pulleys are rotated. Correct. So the frictional resistance develop all along the contact surfaces. This makes the belt carry the follower, which to start rotating. And we have to transfer the motion from one to another. That is from that driver pulley to the follower using the belt. Correct. So we are interested in the friction of force in between the two contact surfaces. So there are two different types of you can say forces that are occurred in the this particular arrangement. So the driving pulley pulls the belt from one side called as a tensile or tight side, tension or tight side, and they deliver it to the other side called as a slack side. So you know that there are two different sides, that is tension side and slack side. The tension T1 in the belt of the tension side is more than the tension T2 on the slack side. Correct. So only then there is a possibility that you can transfer the power from one place to another. So there should be, you can say this is the condition. The tension T1 of the belt should be always more than tension T2. That is tension T1, that is tension on tight side is always greater than the slack side. Okay. Again, that depend on the diameters. So in this arrangement, you can see the bigger pulleys to the left side and smaller pulleys towards the right hand side. Correct. So that's why tension is more in the bottom part, and at the top there is a less tension, or you can say it is a slack side. Now suppose the condition is, say we are changing the condition, that is small diameter pulley to the left and then bigger pulley to the right, then the situation may change. That is, you may get the tension side on the top and slack side on the bottom. Another arrangement of belt is called as a cross and also compounding belting. Now these are the diagram. So diagram itself will explain what is cross and compound belting. Correct. So if the cross belt system is used, the rotation of pulley will be in opposite direction. So this is the again you can say depending on the application requirement. Whenever you want the rotation of first pulley and second pulley should be in opposite direction. In that case, you have to go for the cross belt system. Suppose you want same rotation from first shaft to second shaft, or from first pulley to second pulley. So in that case, you can go for the open belt system, just like this. So this is open belt system where, so this is the, say, a clockwise motion. So it will again rotate the second pulley in clockwise direction. So this is the cross belt system. Another important concept here is the angle of contact in the system of drive. So you can again expect some question based on this also. Angle of contact, that is theta value. Okay. So it varies from, or you can say it is different for open system and cross belt system. When number of pulleys are used to transmit power from one shaft to another, then we can go for the compound drive. So this is the example of compound drive. So there are four different pulleys. These pulleys are, you can say, motion of first shaft is transferred to, you can say, pulley number two. Then as pulley two and three are mounted on the same shaft, so you will get the motion to, you can say, pulley number three also. And as this fourth pulley is attached with the help of this belt drive, so again this fourth pulley, or you can say fourth shaft, will again rotate. Again see the direction. So as the number of pulleys are four, so you can get the like rotation, or clockwise to clockwise. Okay. So this is again most important concept in the belt drive. What should be the length of the belt? So you may expect the question on this also. The question related with the length of belt when it is an open belt system or when it is a cross belt system. So basically we are interested in this particular distance x. So you can say this is the you can say distance between the centers of the two shaft. This is R1 is the radius of the this first pulley, and R2 is the radius of the second pulley. Okay, so first we are given in the problem that these are the given data R1, R2, and X. Okay, now it is expected how much is the length of the belt. So for that, again, with the help of this particular diagram, you have to solve some expression. So at present, we are not going into details regarding how to solve the expression. We are directly switching over to the how much is the length of the belt in case of a open belt system. So say this is the, you can say, last equation. L is equal to pi into R1 plus R2 plus R1 minus R2 whole square upon X plus twice X, where X is the distance between the two centers of the, you can say, pulley or shafts. Then R1 and R2 are the radius of bigger and smaller pulley respectively. So you have to put the values whatever given in the problem, and based on the values you have to then calculate the value of L. So you may expect some questions on this L also, that is length of the open belt. Now see, this is the arrangement of the cross belt system. So again here you will get some, after solving the problem or after going into details of the expression, you are getting another value of L, that is L is equal to pi R1 plus R2 plus R1 plus R2 whole square upon X plus twice X. So this is the only difference. In the open belt system, it is R1 minus R2, whereas in case of a cross belt, it is R1 plus R2. So you have to mug up these, you can say, expressions for getting the values of either open belt system, length of open belt system, and length of cross belt system respectively. So see, this is R1 minus R2 whole square, and in this equation it is R1 plus R2 whole square. Okay. So again, one important note is there. The length of cross belt is always more than the open belt system. Other condition remaining the same. Why? Because it is a cross one. So naturally the length of the belt will increase. So that's why from this particular two equation, suppose we put the values of X, then R1 and R2 in the two different equation of open belt and cross belt. Same diameter, same radius, and same distance X. So the length of cross belt always more than length of the open belt. Okay. The total length of cross belt is R1 plus R2, whereas it is R1 minus R2 for the you can say open belt. Now this is another concept, that is ratio of the tension, T1 and T2. So we know that T1 and T2 are the tension on the tight side and tension on the slack side, correct? So these are the two tensions given, and at the same time you can say power. So in that case you have to go for the equation power P is equal to T1 minus T2 multiplied by V, where V is equal to 2 pi n by 60. Okay, so from this equation you can easily calculate the value of power, or suppose power is given, so you can easily calculate the value of T1 and T2 if any one tension is given in the problem. At the same time you require some speed, so that speed values are again given in the problem. So you may expect such type of question as a MCQ in the gate examination also. So this is another equation, T1 upon T2 is equal to e raised to mu theta. So where this theta is the angle of contact in radian, then mu is the, you can say, coefficient of friction, and T1 and T2 are the tension on the tight side and slack side respectively. So there are only two equations used for getting the value of T1 and T2, or getting value of theta, or getting the value of say power, or getting the value of En. So that two equations are power P is equal to in bracket T1 minus T2 into V. So this is first equation, and second equation is T1 upon T2 is equal to e raised to power mu theta. So you have to put the values in the equation, and you have to get the required answer, whatever asked in the examination. Then another drive is the rope drive. So this is everything about the, you can say, belt drive. Now what is rope drive? Now this is one schematic diagram is given. So here it is a trapezoidal portion of a belt, also called as a V belt, and this is a circular, you can say, rope or belt, but instead of belt it is called as a rope. Okay, so whenever you are going for such type of arrangement, so you can say you are using the rope drive. So whenever you want to transmit more power from one place to another, and when you want a minimum, you can say, the slip between the belting arrangement, in that case you have to go for the V belt drive, or also a rope belt can be used for the transmission of power. So again, here you will get the equation as T1 upon T2. So see at the bottom, we are not going into details of the expression. So this is the equation we are getting after solving this expression T1 upon T2 is equal to e raised to a mu cosec alpha multiplied by theta. In earlier case, it was for flat belt drive, it was T1 upon T2 is equal to e raised to a mu theta. Now here, instead of mu, you have to multiply it by the cosec of alpha. Now see, alpha is this particular angle of groove. This is again angle of groove. So you have to keep in mind such a small changes. है ना? Otherwise, when it is asked in the problem that you have to use V belt drive and you are solving the problem by say flat belt drive, then you may get the wrong answer or zero marks. Correct? So you have to keep close watch on the diagrams and what are the formulas that are used for finding the tensions T1 and T2. So only difference is here T1 upon T2 is equal to e raised to power instead of mu theta it is mu into cosec alpha where alpha is the angle of groove. So this is the angle of groove. It is 2 alpha, generally it is 2 alpha, 22.5 it is given. So you may take it as 22.5 divided by 2. Now another drive is a gear drive, also called as a tooth wheels. So major problem in the belt and rope drives are the you can say slipping. So there are more chances of slipping after the you can say continuous use of the belt. So it may leads to the slipping of the belt over the pulleys. So to avoid that, we are going for the next drive that is a gear drive. So the slipping of belt or rope is the common phenomena in the transmission of motion or power between the two shafts. The effect of slipping is to reduce the velocity ratio of the system because in transmission of power we are always interested in the velocity ratio. It should not change during the operation. Suppose we are getting the output less than the expectation. So in that case, in such type of drive, we can say we are getting the output not as per expectation, and this is only because of the velocity ratio issues. So it will, because of this sleeping, it will reduce the velocity ratio. Say for example, in precision machine in which a definite velocity ratio is important, as in the watch mechanism. The only positive die is by means of a gear or a tooth wheels. So we are always expected that the watch should show the correct timing. So this is only possible through the transmission of motion from one gear to another. And again, important here is the transmission of power using the same velocity ratio. So you know that there are different gears that are attached. So that arrangement we are calling it as a compounding arrangement of the gears. Correct. So here the main intention is that velocity ratio should not change from one gear to another gear. So that's why we can call it as a positive drive. A gear drive is also provided when the distance between driver and follower is very small. Exactly opposite to the you can say flatbed drive. In flatbed drive, there is a considerable distance between the two shafts. Whereas in say example in watch mechanism or assembly of gears or compounding gears arrangement in the watch, you know that the driver and the follower distance is very small. Correct. So whenever you are interested in transferring the power from one to another place, and when the distance is the main criteria, selection criteria for the drive, and suppose here as you are interested in the smaller distances, so that means you have to go for the gear drive, also called as a tooth wheels. So gear is a wheel provided with a teeth which mesh with the teeth of the another wheel or onto a rack so as to give a positive transmission of motion from one component to another component. Correct. They are commonly used for transmission of power for changing the power speed ratio in a power system when the distance is small and when the constant velocity ratio is desired. Again, suppose you want to more power. So in that case, you have to keep the different diameters of the driver and follower. If you want lesser, you can say power transmission. So again, you have to change the diameters. Suppose you are keeping the both diameter of driver and follower as the same. So in that case, the power transmission is at constant phase. Correct. Suppose you want a lesser power transmission. So in that case, you have to keep the diameters of driver and follower different. Consider two plain circular wheel A and B mounted on the shaft, having sufficient rough surfaces and pressing against each other and rotated in opposite direction. So we are talking about some frictional resistance between the two wheels. So it is not a gear. It is a, you can say, a frictional wheels without tooth or without teeth on the surface. The wheel B will be rotated as long as the tangential force exerted by A does not exceed the maximum frictional resistance. Okay, so here important concept is again the tangential force should be exerted by wheel A does not exceed the maximum frictional resistance. Correct? But when the tangential force exceeds the frictional resistance, the slipping will take place. And we are not interested in such type of situation. Correct? So to avoid that slipping, we are preferring the drive like the gear drives. So say this is the example given. So this is the first frictional wheel. This is second frictional wheel. So power is transmitted from this particular wheel to this wheel only when the frictional force is more than sorry, tangential force is more than the frictional force. Only then there is a transfer of power from one place to another place, or from one shaft to another shaft. So again, condition is that these two wheels should be comes in contact with each other. Only then you can transfer the power. Now, what we are saying that if the tangential force exceeds the frictional force, then the slipping takes place. Okay. So this tangential force P, suppose this is more than the frictional forces. So indirectly there is no friction between the contact surface. So in other words, we can say there is a slipping of the this particular friction wheels. Now again to avoid that, we are just switching towards the tooth gears or tooth wheels. Correct. So in order to avoid this slipping, a number of projections called as the teeth are provided on the periphery of the wheel A, which will fit into the corresponding races on the periphery of the wheel B. So you can say, in other words, there is no slipping of the you can say gear 1 or gear 2. So whatever the expectation, exactly the same velocity ratio is transferred from gear number 1 to gear number 2, or from driver to the follower. A friction wheel uh, with the teeth cut on its surface is known as a tooth wheel or a gear. The usual correction to show the tooth wheels is by their pitch circle. So we are interested in this much, this particular diameter, this center one. Whenever you are going to purchase some gear, so you have to give the this particular, you can say, diameter, that is a pitch circle diameter, while purchasing the gear. So in other words, you can say it is a designation of the gears. So it is designated with the pitch circle diameter. So due to the possibility of slipping of the wheel, the friction wheels can only be used for transmission of the small powers. Correct? Because there is a chance of slippage. So you cannot use this particular system or arrangement for the transmission of the maximum power or more power. So it is only suitable for the small power transmission. So this particular disadvantage is overcome by using such type of arrangement of gears. So this arrangement, in this arrangement, you can go for the transmission of higher power also. So there are some advantages over the flat belt drive or rope belts. So it transmits exact velocity ratio. It may be used to transmit large powers. It has high efficiency. It has reliable service. It has a compact layout. But still there are some disadvantages also associated with this drive. The number one most important is the manufacturing of gears. It requires special tools and equipment. You know that this generally this type of gears are manufactured on the CNC machine or on the hobbing machines, automated machines. Correct. So it requires special tools and equipment for manufacturing the gears. The error in cutting teeth may cause vibration and noise during the, you can say, operation. So to make the operation noise proof or less or zero vibration, you have to manufacture the gears more precisely using the sophisticated tools and equipments. This is the classification of gears or also tooth wheels. So basically, they are classified on the basis of four different heads. That is according to position of the axis of the shaft. The axis may be either parallel, intersecting, non-intersecting, and non-parallel. So depending on the arrangement of the axis of the shaft. So this is the first classification. The second is based on the velocities of the gear. It may be either low velocity, medium velocity, or high velocity. Suppose you want to transfer 15 meter per second square, 15 meter per second velocity. So in that case, you have to go for the, you can say, high velocity drives or gear drives. And suppose it is less than 3 meter per second, then it is called as a low velocity gears arrangement. The third classification is the according to type of gearing. So you might have seen the different arrangements. So you have seen the external gearing is there, the internal gearing is there, and sometimes also rack and pinion arrangement is also there. So based on these three, it is called as a type of gearing. Then according to position of the teeth on the gear surface, the position of the gear teeth may be either a straight one, inclined one, or curved one. So based on this, it may be either spur gear, helical gear, herringbone gear, bevel gear is there. You know? So in this fashion, you can see these are the different classification of gears. So this is the first arrangement, that is according to the position of axis of the shaft. It may be either parallel, intersecting, or non-intersecting and non-parallel. So first is the spur gear. So these gears have a teeth parallel to the axis of the wheel. Now this is not a spur gear. This is a helical gear. So assume these are the, you can say, axis of the gear or teeth. Suppose it is exactly parallel to the axis of the, you can say, shaft or axis of the wheel. In that case, you can say it is a spur gear. Now this is the case of helical gear. You can say this is the uh, spur gear, where the axis of the gear tooth is parallel to the axis of the wheel or axis of the shaft. Another name given to spur gearing is a helical gearing, in which the teeth are inclined to the axis. So these are the arrangement of, say, single helical gear and double helical gear. So this double helical gear arrangement is also called as a herringbone gears. So use of the type of gear is again depend on the application or use. Now another arrangement is given here is a bevel gear arrangement and a spiral gear arrangement. The two non-parallel or intersecting but coplanar shaft connected by gear are called as a bevel gear arrangement. So whenever you want to, suppose for example, you want to transfer the power from one place to another, and this both the shaft or two shafts are at 90 degree with each other. In other words, the axis of the shaft 1 and shaft 2 are at 90 degree with each other. So in other words, you can say the power is transferred from first shaft to another shaft when the axes are at 90 degree. So in that case, this bevel gear arrangement is used. Okay, the bevel gears like spur gear may have their teeth inclined to the face of the bevel, in which case they are called as a helical bevel gear. The gears which are engraved on the surface of the blank is a helical gear, but the arrangement is called as a helical bevel gear arrangement. As we are transferring the power from one shaft to another shaft, the shafts are non-parallel, but they are intersecting. Now see here, both the axes are intersecting at a common point, though it is not at 90 degree, but you can treat this as also a bevel gear. I have given you example when the axis of first shaft, and second shaft is at exactly at 90 degree. So in that case, again, you can transfer the motion from one place to another. The two non-intersecting, non-parallel. So say this is the arrangement. The two axes are non-parallel. At the same time, they are non-intersecting. That is, they are non-coplanar shaft connected by gears. Then the arrangement is called as a skew bevel gear, or also called as a spiral gears. And the arrangement is gearing, spiral gearing arrangement. The second classification is based on the peripheral velocity. I already told you this classification. When the velocity is 3 meter per second square, then it is called as low. 3 to 15, it is called as medium. And suppose you want to transfer more velocity, that is more than 15 meter per second, you require more power. So in that case, it is called as a high speed gearing. The third classification is according to the type of gearing. It is either external gearing or internal gearing. Now see the arrangement. The first diagram shows here it is a external gearing. Two gears comes in contact with each other, and first gear is rotating in anti-clockwise direction. The other gear will rotate in clockwise direction. So this is the case of external gearing, and this is the internal gearing. When one gear, that is bigger gear, and to that bigger gear there is another gear which is rotate from inside, and the direction, see the direction of the both gear is same, like. So it is a case of internal gearing. Then another arrangement is the spur gear, oh sorry, rack and pinion arrangement. Okay, so it is again a type of external gearing. So in this arrangement, the gears of two shafts meshed externally with each other. The larger of these two wheels is called as spur, and the smaller is called as a pinion. In external gearing, the motion of the two wheel is always unlike. यहाँ पे देखो आपको, you will clearly see it is unlike motion. This is like, and this is again like. Suppose this is moving in clockwise direction, so this rack will move in again forward direction. That is in same direction. In internal gearing, the gears of two shafts are mixed internally with each other. The larger of these two wheels is called as the annular wheel, and the smaller is called as a pinion. In the internal gearing, the motion of the two wheels is always like. Sometimes the gear of the shaft meshes externally and internally with the gears in a straight line. Such type of gears is called as a rack and pinion arrangement. The straight line gear is called as the rack, and the circular wheel is called as the pinion. With the help of rack and pinion, we can convert linear motion into rotary motion and vice versa. So suppose you want such type of application where you want to transfer the linear motion to rotary motion. So such type of arrangement is not possible in the, you can say, internal gearing and external gearing, because here there is no linear motion. So you are getting the linear motion in only rack and pinion arrangement, whereas the you can say rotary motion of pinion is transferred to the other element, and you are getting the linear motion on the rack. Okay. Now fourth classification is according to the position of teeth on the gear surface. The teeth on the gear surface may be either a straight one, inclined one, or a curved one. The spur gears have a straight teeth, whereas helical gears have their teeth inclined to the wheel rim. In case of spiral gear, the teeth are curved over the rim surface. Let me check the diagram of spur gear. This is the internal gearing arrangement. This particular. This is rack and pinion arrangement. Correct. This is again rack and pinion arrangement. So depending on the application requirement, you have to use different arrangement of the gears for transferring power from one place to another. Now this is another most important topic for the gate examination. That is the terminology that is used in the gear, also called as a nomenclature of gears. So there are, I think, more than 20 terms associated with this particular diagram. So it is very easy to remember all the you can say terms associated with this diagram. You have to only do one thing, that is you have to first draw the front view. So in the front view, this particular portion is only visible. Only concentrate on this front portion only. So whatever the terms that are visible in the front view, you can write that terms first. Say for example, this addendum and dedendum. This is visible in front view, correct? This face width, or you can say addendum circle, top line, face, flank. This is not visible in the front view. So we are not concentrating on these terms right now. We are only concentrating on the whatever the terms that is visible in the front view. Okay. So these two terms are visible. Then another term, that is toothpaste, is visible. Then this addendum circle, dedendum circle, these are also visible. Total depth is visible. Then clearance is visible. Then clearance or working depth circle is visible. Piece circle is visible. Working depth is visible. Okay. So these are some of the you can say terms that are visible from the you can say front view. Then from the top, or from you can say second view, suppose we are taking it as side view. So you can see different terms like flank, face, then piece surface element, then face width. So these are the four terms that are associated. Also this no, this is also visible in the you can say front view. So only four terms are visible in the side view. So there are few terms you are getting from the front view, few terms from the side view, and also you can say top view. So from top view, you are getting the face width, then top line. So these are the terms associated with the gear, but it is clearly visible in the top view. So in this fashion, you can remember the diagram and at the same time the definitions of the terms, because generally such type of you can say terminology is asked in the examination for MCQs. Suppose you are going for some competitive exam, also technical competitive exam. I am talking about that exam. So you may get such type of questions. Most of the you can say these particular definitions or terms, they are little bit confusing. You know? So you have to remember all these terms by drawing the diagram. See, first particular definition is regarding the piece circle. Say this is the piece circle. I already told you in the earlier diagram also that whenever you are going for the purchase of the gear, you have to give this particular diameter, that is piece circle diameter. All the gears are generally designated on the basis of the piece circle diameter. So it is the imaginary circle which by pure rolling action would give the same motion as the actual gear. So this particular line, that is 1, 2, 3, 4. There are four different circle lines. So second line, it indicates the piece circle, and the diameter corresponding to this particular circle is called as the piece circle diameter. It is also called as a pitch diameter. Then another definition is a pitch point. It is the common point of contact between the two piece circle. Whenever two gears comes in contact with each other, so generally they are comes in contact with each other at a common point. So that point is called as a pitch point. Okay. Next is the pitch surface. So it is the surface. Now see here, where is the pitch surface? So this is the pitch surface. It is visible in side view. Correct. So this particular point we are calling it as a pitch point, and the surface is the pitch surface. It is the surface of a rolling disc which are meshing gears have replaced at the pitch circle. So in other words, you can say it is a line contact. The other tooth is comes in contact with the first one at this particular line. So this is called as a pitch surface element. Then most important is again a pressure angle, also called as a obliquity angle. So it is the angle between common normal to the two gear teeth at a point of contact and the common tangent at the pitch point. So it is usually denoted by degree, and the standard angle are 14.5 degree and 20 degree. So if it is not given in the problem, so you can directly take these two angles in the or while solving the problems. Pressure angle 14.5 degree or 20 degree, or you may expect the MCQ on this particular topic also. How much is the angle of obliquity in case of a gear? So different varieties, different options are given, and out of that options you have to select the correct one. So correct answer is 14.5 to 20 degree. Then circle, that is addendum circle, dedendum circle, and their distances, radial distances. So radial distances are called as either addendum or dedendum. Whatever the radial distance is above the P circle line, so that particular distance we are calling it as a, this particular distance we are calling it as a addendum, and the distance below the P circle is called as a dedendum. It is a radial distance, linear distance. So it is the radial distance of a tooth from the P circle to the top of the tooth. Then dedendum is, it is the radial distance of a tooth from the P circle to the bottom of the tooth. Then the circles corresponding to this addendum, dedendum are called as a, you can say, addendum circle and dedendum circle respectively. The circular pitch, it is the distance measured on the circumference of a pitch circle from point of one tooth to the corresponding point on the next tooth. So that distance is called, we are calling it as a circular pitch. So this particular distance we are calling it as a circular pitch. Distance between this point and this point. Suppose we are measuring this distance linearly. So in that case, we can say it is a simply a pitch. But as it is a curvature that is circular, so that's why it is called as a circular pitch. Distance measured on this on the circumference of P circle from a point of one tooth to the corresponding point on the next tooth, and generally it is represented by PC. Again, you may expect the question based on these different diameters. Okay, the diametral pitch, it is the ratio of number of teeth to the pitch circle diameter in millimeter. Suppose in the examination, diametral pitch is given and PCD of the circle is given, and you want to find the value of what are the, or how much is the number of teeth on that particular blank or on the gear. So that can be easily find out using this particular relation. So it is the ratio of number of teeth to the pitch circle diameter PCD of the gear in millimeter. Now next is module. So it is exactly opposite, or you can say reciprocal of the pitch circle diameter. So it is denoted by small m. Mathematically, it is d upon t, diameter PCD divided by number of teeth. The clearance. So this particular gap is called as a clearance. See this gap is called as a clearance. So it is a radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. So in other words, there is always a gap of this much value when the other gear comes in contact with this particular gear. So other face will be up to this particular position only. So there is always this gap. This gap is provided for the expansion purpose. As the both gears are comes in contact with each other, so there are frictions involved in that. So because of the friction, there might be chances that it may the temperature of the tooth may rise. To accommodate that particular, you can say, rise in the temperature or rise in the dimensions of the gear tooth, some gap is provided. So that gap is nothing but it is the clearance. So it is below the, you can say, working depth. So this total, you can say, this is the working depth. So this is the working depth, and below that there is a one gap. That gap is called as clearance. It is again a radial distance, linear distance. Then total depth. It is the radial distance between the addendum and dedendum circle of the gears. It is equal to sum of the addendum and dedendum. So whenever total depth is asked in the problem, so you have to add the two values of addendum and dedendum. Then working depth, it is the radial distance from the addendum circle to the clearance circle, and it is equal to sum of addendum of the two meshing gears. So these are again some definition associated with this particular diagram, that is a gear terminology. Tooth space, then backlash, tooth thickness, face of the tooth, flank of the tooth, then top line, face width, then profile, the fillet radius, path of contact, length of path of contact, then arc of contact. Again, there are two different arcs associated with this particular gear terminology, that is arc of approach and arc of recesses. Now, next is the types of gear train. So basically, there are four types of gear train. So this is again based on the arrangement of the compound one, reverted one, or epicyclic one. So quickly going into details of this arrangement. So this is the simple gear arrangement. Here you can see the direction of the rotation. This is clockwise, this is anti-clockwise. So this is first arrangement. Second arrangement is just by involving one gear. That gear is called as a idler gear. So whenever you want the same motion, that is direction of motion, so in that case you have to use the idler. So this is another arrangement when the directions are opposite. First gear is called as a driver, another last one is called as a driven, or also called as a follower. So this is a compounding gearing where there are more than one gear mounted on the one shaft. So such type of arrangement we are calling it as a compound gear trains. So the arrangement is shown here. The riveted gearing. Again, there are more than two gears are mounted on the shaft. See here, 1 and 4 is mounted on the first shaft, and 2 and 3 are mounted on the second shaft. And motion of gear number 1 is transferred to the motion of 4. So such type of arrangement is called as a reverted gear. Now last gear is a epicyclic gear trace. So see here, this is the fixed point where about this particular point or O1, this particular gear rotates, and about point O2, gear number B or gear B is rotating. And there is a contact between these two, and another arm is used, okay, to connect the two gears. So whenever you want some different motions, say suppose you want the motion of this B or around the gear number 1 or gear number A. So this particular gear will rotate like this around center O1. So such type of application, or you can say arrangement, is called as a epicyclic gear train. EP means the upon and cyclic means the round. So second gear is moving around this gear number 1. So there is only one you can center of rotation, that is O1. So this arrangement is called as a epicyclic gear trains. So I think this is all about the gear train and the belt drive. So you may expect different question, variety of questions from the belt drive, the gear drives, then the gear trains also. So you can go into details of the whatever the formulas are there. So first is the velocity ratio, then second is angle of contact, then what are the different tensions. So there are again two different variety of velocity ratio, that is during the, you can say, when there is a slip between the two pulleys and bend, and when there is no slip and with slip. Say some values are given to you, say a slip of say 5% on the drives. So in that case you have to take that value S1 is equal to S2 is equal to 5%. So that value you have to take, and then you have to calculate the different values of you can say speeds, that is N1, N2 in case of simple drive, and in case of say compound drive N1, N2, N3, N4. So that again depend on the number of gears attached in the assembly. Then again, you may expect the question on the length of open belt drive, then length of an cross belt drive. So L is equal to R1 plus R2 plus 2x plus in bracket R1 minus R2 whole square upon x. So this is in terms of you can say radius. So suppose we are replacing the radius by diameter. So your equation becomes pi by 2 d1 plus d2 plus twice x plus in bracket d1 minus d2 whole square divided by 4x. So in this fashion, you can get the values of length of open belt. Now only difference in the equation of length of cross belt is instead of minus there is a plus sign in the expression, that is R1 minus R instead of R1 minus R2 whole square you have to take value as R1 plus R2 whole square. So this is the case of you can say length of cross belt drive. Then again, you may expect the question based on T1 and T2, that is tension on tight side and tension on slack side. So you know the formulas. Say for example, power transmit is equal to P. So that value is equal to formula is T1 minus T2 multiplied by V, where V is the you can say velocity or speed is equal to 2 pi n upon 60. So value of n is already given to you in the problem. And another equation is that log of T1 upon T2 e raised to power mu theta. Suppose you are not using the value of E. So in that case, you can use equation as 2.3 log T1 upon T2 is equal to mu theta. है ना? Instead of log to the base E, you can go for 2.3 log. So using these two equations, you can easily find the power transmitted or tension or tight side and slack side. Then another question you may expect on the angle of contact. Now this angle of contact is also called as a angle of lap. Correct. So again, there are some questions based on this also. You may expect the question on that. Also, you may expect question like if centrifugal tension is given. So that value you have to consider in the T1. You know. So based on this T1, T2, and TC, you can again easily calculate the different unknown values. Again, I think this much is sufficient for today's lecture. If you have any doubts regarding the whatever we have discussed till now, so you may ask within say 5 minutes. Still, I think 2 to 3 minutes are there. So you may ask the question based on this.
Any student want to ask any question? Hello? Any doubt that you want to ask to our expert? Or we should conclude the session here? No doubt to anyone? Okay.
Sir, I want to add here one thing that
Okay.
students, you have to refer that Ratan book for the these particular topics, or you can say complete theory of machine topic. And at the same time, another good book is the Khurmi book. So you may refer that book also. So everything is given in that two books. So I think these two books are sufficient for the topics covered in theory of machine.
Okay,
Okay.
thank you, sir. I
Okay, sir.
think there
Thank
is
you.
no doubt from the student side.
Okay, sir.
So we should conclude the today's session here.
Okay, sir. Okay.
Thank you. Thank you very much, sir.
Thank you. Thank you, sir.